Hi all, this is Bharat. My roll number is 21951 A0522. Today my topic is about an introduction to soft core processors and biomedical applications. Let's get started. First of all, we will discuss what are the soft core processors. Uh, Microcontrollers are a familiar to most electrical engineers. The word microcontroller is commonly associated with the PIC and 80 mega chips and development boards such as the and by a few of the popular and widely supported microcontrollers and development boards in use today by makers, students, and hobbyists. Yeah. The next point is my microcontrollers packs a lot of functionality on a single chip, but for bigger or faster tasks, one may have to turn to FPGAs. When FPGAs are maintained, engineers often begin to sweat a little. For many, FPGAs brings back memory of digital design and painful lines of hardware description language, that is HDL. Now, modern design tools have changed this and allow anyone needing the flexibility and perform of a FPGAs while avoiding the difficulties of HDL programming. So, softcore processor is a program pre-written in HDL that provides a processor code that runs on a FPGA. It allows the programmer to define such a general purpose input-output lines, that is GPIOS, uh, series parallel interface, that is SPIS, and universe asynchronous receiver and transmitter at compile time, so he or she can design a powerful IDM system uniquely customized to his or requirements. Need a system with 40 plus with modality, that is PWM, sorry, PWM outputs, a 16-bit wide parallel output port and 12 series ports. No problem with the design tools available today. One can design an embedded system with a soft processor without writing a single line of HDL. FPGA design tools such a why define the software processor using graphical drag and drop operations. Then the C++ program that runs on the software processor is compiled using a different design tool such as software development kit, that is SDK. On power up, the hardware design is loaded onto the FPGA to create the software processors and any additional defined peripherals. Then the C++ program is loaded onto the software processor and finally the program executes. Now, FPGAs have developed boards just as do many microprocessors. These development boards are a great place to start designing systems that use a soft-core processor. A later new development board for the 7 FPGA is a by Dilate. Now, what makes the artificial interesting is that it was designed with the microprocessor soft-core processor in mind. The ARTY reference page provides survival getting started example using the microbits. The ARTY supports 256 MB of external random access memory, that is RAM, external flash memory for storing both the FPGA binary definition file and the C program it runs, and USB port to program the device. In terms of input output, that is IO, the ARTY boards the mm, unique footprint and connectors, switches, push buttons, and red, green, and blue light emitting diodes. Now, the advantages we'll see the advantages of self-core processors. In the design environment, digital logic is defined using a block diagram rather than writing a traditional HDL code. That's right, no HDL is needed. Those who have used LabVIEW will see some similarities with using the Vivid block design tool. Adding a self-core processor such as the microbase become as easy as dragging and dropping from the toolbox, and it prefers the defense using a setup guides. Uh, Wiring blocks are done by simply clicking and dragging. Vivid even automatically makes the basic connection to implement bare bones microcontroller functionality. Yeah, in this advantage, the first advantage tells that mm, digital log is defined using a block diagram. The block diagram is this. There is a microbliss diagram. There is a program that input will gain an input, and the figure shows that the part of block design implementing a microbliss soft core processor. This shows the easy in implementing a soft core processor using powerful design tool such as VWAT, which turns soft core microprocessor design into drag and drop operation. Part of a program designed to run on the microbliss that configures it a GPIO and SPI interface at runtime. Programs are written in C++ language. uh, Moving from the prototype phase to the product with the FNGA is also much more complicated than using microcontroller. The real world applications are at the Virgin Military Institute, Profit, in this course, Senior Electrical. It involves creating a front-end graphical user interface that is UI running on the PC written in C hash that committed to real-time phase local differential and amplifiers run by microcontroller. controller. The annual subscription design and PC controller interface turned out to be reflective to the logic subsystem of the branch. The annual AD, if 18 bits of debit. The solution came by RT development, that is 7 FPGA and 256 of RAM, all on a easy to prototype development board. We use it to Tensor microcontroller for all the non-negative main functions, including using the USB port to upload the data to PC. And then it provide the data to the tensor in choose using a simple and shaking protocol for the tens to send back to the PC for analyzing display. The charts to the all the transfers. That's all. Thank you.